At this time, I'd like to introduce our presenter, Krista Poss, Marketing Manager for System Sensor. Krista, take it away.
Thanks, David, and welcome everyone. Thanks for taking time out of your schedules today to attend this webinar on intelligibility. So now let's go over what we're going to be covering in the next 45 minutes or so. The first thing we'll look at is NFPA 72, the new 2010 edition. There was a big update to the code in regards to intelligibility, so we'll talk about some of those changes. Next, we'll talk about some of the factors that can affect intelligibility, such as room dimensions and materials, ambient noise, speaker choices, and other factors. After that, we'll look at some of the system sensor speakers and speaker strobe devices that are also part of a voice evac system. And finally, I'll provide a live demonstration of a new voice evacuation design software. This is from AFMG Technologies, but we think it could be very helpful to those of you who are designing and installing voice evacuation systems, so we wanted to bring it to your attention. So first, let's take a look at the new intelligibility code. As I mentioned already, the 2010 edition of NFPA 72 has refined its section on intelligibility significantly, including some key terminology and definitions. It now defines intelligible as capable of being understood, comprehensible, and clear. And of course, intelligibility is defined as voice communications having the quality or condition of being understood, comprehensible, and clear. Okay, now an acoustically distinguishable space, or an ADS for short, is one of the most important new definitions in NFPA 72. And you'll be using this term a lot if you're designing or installing systems that require intelligibility. So NFPA defines an ADS as an emergency communications system notification zone, or a subdivision thereof, that might be an enclosed or otherwise physically defined space, or that may be distinguished from other spaces because of different acoustical, environmental, or use characteristics such as reverberation time and ambient sound pressure levels. So now let's talk about who identifies ADSs and how are they used in the design and installation of an actual voice evacuation system. The code covers the application of ADSs in Chapter 18, which is notification appliances. So first, it is the system designer who determines how a space or facility should be broken down into specific ADSs in the planning phase of the project. And the designer also determines if intelligibility will be required in each distinct ADS. And of course, when or where required, the code also makes allowance for the AHJ to review and approve once the plan is completed. So let's look at ADSs in a little bit more detail. So as you know, ADS designations are established at the beginning of the project. Specifically, the designer makes decisions about ADSs based on the building characteristics and usage. Typically, the designer will segment the building or space based on the physical barriers. So we're looking at walls and doors, any material changes like different types of material used on the walls, ceilings, or the floors, and the expected ambient sound levels for that space. Once these designations are made, the designer will then decide if each specific ADS should and will require intelligibility in that space. The same type of factors that drove the ADS designations will come into play here. For example, if expected ambient noise level in an ADS will make it virtually impossible to make a voice system intelligible, the designer can then decide that the ADS will not require intelligibility. And this approach has been implemented to avoid costly and ineffective over-design of voice systems and to avoid intelligibility testing in areas that are deemed impossible. So in this case, maybe the designer says we're going to use a different type of notification appliance here, and they opt for strobes or a horn in this type of situation. Another potential ADS designation is that intelligibility is required but not measured. In these ADSs, intelligibility is required, but testing might not be practical or necessary, such as in hotel rooms or certain office environments where audibility is easily being met and you wouldn't have to go in and measure intelligibility in each of those spaces. These requirements drive the intelligibility process, which can be broken down into 4 main steps, which we'll walk through now. First, ADSs are assigned by the designer. If intelligibility is not required in an ADS, then the process is complete for that area. If it is required, then the designer decides if intelligibility needs to be measured. If not, this completes the process. If it is, then either subject-based or objective measurement approaches must be chosen and utilized. Subjective measurements typically involve groups of trained listeners in the space listening to a voice message and then determining if it is intelligible to them. Objective measurements use an intelligibility meter, which most of you are probably familiar with, that measures the intelligibility of a voice message against an objective scale. So this would either be an STI or CIS score. Other additions to the intelligibility code include the new Annex D and acceptability criteria. So Annex D is brand new, and it's intended to provide guidance on planning, design, installation, and the testing of voice evacuation systems. And the majority of this annex contains recommendations for testing of the intelligibility of the voice system. So I would recommend for anyone who is new to these code changes or is now designing and testing systems, Annex D is a great place to start to get a lot of background information and learn more about the new requirements. The acceptability criteria state that the intelligibility of an emergency communication system is considered acceptable if at least 90% of the measurement locations within each ADS have a measured STI of not less than 0.45 and an average STI of not less than 0.5. So on the STI scale, it's a scale from 0 to 1. So what NFPA is looking for is right in the middle of that scale, a 0.5. So I think that's considered a fair score on the STI scale. Okay, David, it looks like it's time for our first poll question.
Thank you, Krista. And we will launch the first poll question and would appreciate all of the attendees in voting on this. So a little product question for you. For voice evacuation systems, do you ever need a speaker larger than 4-inch and tapped higher than 2 watts? So for those of you that may have been involved in voice evacuation systems in the past, if you would, please go ahead and answer this question. So yes, frequently. It's something that's part of nearly all of your projects. Yes, but infrequently. Perhaps it's used only when specified or in certain instances. And then no. So we would appreciate you taking a vote now. We'll give you a few more seconds. We'd love to get 75 or 80% of our attendees to vote on this response. And I didn't tell you this before, but as promised, or as I will promise, we will share these results with you. So on the 3 poll questions, we'll share those results. All right, thank you very much. We're at 75%, so I'm going to close the poll. And as promised, I'll share those results. So Krista, it looks like 16% said yes frequently, about 54% said yes, but infrequently, and then 29% said no.
Okay.
So, and I would remind attendees, if you do have a question for Krista or any of the material that Krista's covering, use the chat feature on the GoToWebinar control panel, and we'll get to those in as close to real time as possible. So Krista, I'm going to take the poll question down.
Okay.
and we'll go back to you.
Great, thank you. So next we're going to look at factors and key drivers that can influence intelligibility in a space. There also are several factors actually that play into intelligibility of a voice system and characteristics of the system. Some of these characteristics can either be changed or designed around in order to improve intelligibility. So first, the signal-to-noise level ratio is simply the output of the speaker versus the ambient sound of the space. And the characteristics that drive signal-to-noise level are the speakers you're using, the type of speaker, how they're spaced, and the volume that those speakers are tapped at, so what wattage setting you're using, and then obviously the ambient sound level in the environment. Another factor, echoes and reflections or reverberation, is related to how sound waves bounce off of objects within the space. So big contributors here are room materials, whether you have plush carpet and soft furnishings, or you have concrete and marble walls, the objects within the space, if they're going to be absorbing sound or bouncing sound off, and speaker placement have a large impact on echoes and reflections. And most times this has a major impact on intelligibility, and this is sometimes something that designers don't have a lot of control over. So if you're going into a space to design or install a system and, you know, it's marble and tile and concrete, that could be a challenge to meet intelligibility scores. Beyond the physical characteristics of the room and voice system, the human factor also plays a part in intelligibility. So for example, the ability of the communicator to speak in a clear, understandable manner, whether it's a live message or a recorded message, can obviously have a large impact on the intelligibility. So characteristics of speech such as someone's accent, dialect, diction, and the frequency of their voice, particularly if it's a male or female voice, are the main drivers of talker ability. Likewise, the listener ability, or the sensitivity of the listener's hearing and ability to focus on a message, also plays a large part in the intelligibility of a voice message. So as we age, we lose hearing across the frequency range. Maybe we can't hear at the low or high ends of the frequency range. And this obviously has an impact on a person's ability to understand the message. The last two factors that we're going to talk about related to the delivery mechanisms of the voice message are the capabilities of the speaker and audio equipment being used. So the frequency response is a quantitative measure of the output of a device in response to a stimulus. And UL 1480 requires that fire alarm speakers be listed between the range of 400 to 4,000 hertz. Obviously, the wider the range, the better quality of the sound that is produced by the loudspeaker. The last factor we'll talk about is the total harmonic distortion. This is another characteristic of the system that can influence intelligibility. Lesser harmonic distortion allows the components in a loudspeaker, the amplifier, or the microphone to produce a more accurate reproduction by reducing harmonics that can be added by electronics. So now that we've covered some of the qualities of speakers that influence intelligibility, let's take a quick look at the System Sensor Spectralearn Advanced speaker line. System Sensor provides a full line of speakers and speaker strobes that are ideally suited to meet intelligibility and audibility requirements of voice evac systems. Our line of speakers and speaker strobes include the SP line, which is a high-fidelity line of speakers that are perfect for crisp, clear messages. And then we also offer the SPV high volume speakers, which produce about 3 dB higher at each tap setting. So these are ideal for areas with high ambient noise, where you just need a louder speaker, or if you're designing a system where you want to use less speakers, the higher volume side might work for you there. These devices use a universal mounting plate with an onboard shorting spring that ensures wiring continuity before the devices are ever installed. So the installers can verify proper wiring without mounting a device and exposing them to potential construction damage. Once the plates are mounted, all Spectralearn advanced devices utilize a plug-in design with a single captured screw to speed up the installation process and virtually eliminate costly ground faults. And Spectralearn Advanced are the only plug-in speakers and speaker strobes on the market for voice evacuation. And finally, we offer field-selectable settings. This includes the candela for the strobes, the speaker voltage, and the power settings. Also includes automatic selection of 12 or 24-volt operation. So installers can easily adapt the devices to meet a very wide range of application requirements. Other features of the line simplify inventory, specification, and installation while expanding your business into the growing voice evacuation market. Like I said, Spectralearn Advanced speakers take up less room in the back box, so it's going to make it easier for installers to dress the wires and avoid those pinched or crushed wires that can lead to ground faults and costly time to troubleshoot those. The devices fit in a standard 4-inch by 2 1/8-inch back box. We do offer accessories to provide more room in the back box if that's needed. And lastly, we offer a full outdoor product line that's NEMA 4X rated, which includes our wall and ceiling devices. And David, looks like we're at our second poll question.
Very good, Kristen. We do have a couple questions from the audience that we'll handle after the poll question. So the next poll question is simple yes, no. Have you been required to measure voice intelligibility on a voice evac system? So if you have projects that have required that, please pick yes. And obviously, if you haven't, please pick no. We realize in some jurisdictions, some ASJs may be applying this code differently. We hear that from time to time. So please go ahead and vote. Thank you very much. You're voting at a great pace. We're right at 80%. So to get back to the presentation, I'm going to go ahead and close the poll. So thank you for voting. And I will share those results with you as promised. So Krista, almost split here. Yes, they have been required 52%, no 48%. So almost an even split there.
Excellent.
So Krista, some of the questions have floated in from attendees here. The first one is asking for clarification. If you have a voice evac system, why wouldn't you require voice intelligibility?
Well, in the code, what we covered is that in the 2010 edition, the language pertaining to intelligibility previously was only in the appendix or the annex of the code. That has now been moved into the body of the code. So prior to this, it was never a requirement by code. So there is more of a focus now as areas and jurisdictions migrate to adopting the 2010 edition to focus on intelligibility and design systems for intelligibility. It of course makes sense that as life safety professionals, we think that yes, all voice evacuation systems should be designed this way because intelligibility is ensuring that the building occupants can understand the message clearly. So, I think it's good business practice, that we want to have systems that are intelligible. But prior to the 2010 edition, it was only in the appendix of the code.
Okay. All right. Very good. The next question, does signal-to-noise level differ between different speaker manufacturers? So system sensor versus maybe the competitors to system sensor.
The signal to noise level is not something that we specify in our data sheets. It's basically the volume or the output of the speaker versus the ambient sound level of the room. So it's not something that you're going to see spec'd on a data sheet.
Okay. Okay. Next question, is there or what is the relationship between a speaker's voice frequency and intelligibility, or is there a relationship?
A speaker, I think I'm confused by the question. A speaker being a person giving the message, or the speaker as in the device?
Why don't we ask for clarification? So here's what the attendee wrote. What is the relationship between the speaker's voice frequency and intelligibility? So and the attendee just said the person.
The person.
Yes. So the person as in the person's voice frequency and intelligibility.
Sure. The only data that I've heard, and I mentioned the female versus male, is that in some instances male voices are used more prevalently for outdoor messages because it's a lower frequency and carries farther, and that indoors female voices seem to get people's attention and people pay attention more to them. But other than that, I don't know that there's a big difference in each person's the frequency response of their voice as compared to intelligibility of a system.
Okay. And another attendee said the term talker might be a better word than speaker. So if we,
yes, good point.
If we wanted more clarification there.
Good point. Mm-hmm.
Krista, I know we have a little bit more content to cover. Why don't we go back to that, and then we'll cover some more of the questions at our next poll break.
Okay, great. Thanks, David. So now we're going to look at a new voice evacuation design software. We believe EASE Evac, which is the software we're going to be talking about, is an innovative software that, as a speaker manufacturer, we hear from our customers that they need help in designing voice evacuation systems to help address the new intelligibility requirements. So please note that System Sensor, we didn't develop this software. We don't sell it. It comes to you from a company called AFMG Technologies. They are the software developer, but we think that it's an interesting new solution that we wanted to introduce you to. So I'm going to go through some of the points of the software, and then we'll look at a live demonstration of how it works. So some of you may already be aware of EASE, which stands for Enhanced Acoustic Simulator for Engineers. This is a software that's been used by sound engineers for quite some time to design high-end sound systems for spaces like theaters, cathedrals, and stadiums. So when we're talking about EASE Evac, it's powered by AFMG's EASE technology, but it's a simplified version that has been specifically scaled to enable system designers to model voice evacuation systems, to obtain predictions of your sound pressure level within the ADS, as well as intelligibility levels, and this is all before installation. Now I want to mention that we're talking about how it's been scaled for the life safety market, and the purpose of it is to be pretty intuitive to use. There's a comprehensive user's guide that comes with the software that really walks you through all of the features and functionality of the software. So that's a great place to get started to learn how to use this for your needs. Currently, EASE Evac comes preloaded with System Sensor Spectralearn Advanced Speaker data for quick and efficient design of voice evacuation systems. Since Spectralearn Advanced devices are the leading AV notification devices on the market, this should be a big benefit and time saver if you are designing voice systems. I'm going to talk a little bit about how the software works. You can import your acoustically distinguishable spaces either by manually inputting room dimensions into the software, or you can import a blueprint and trace the dimensions within as well. So it accepts JPEG, TIFF files, CAD files, and that's the way you can get your room within to the space as well. It includes an absorption materials database. So we talked about the room furnishings being a key piece of the intelligibility puzzle. So you will have to go in and tell the software what type of materials are you using on your walls, your ceilings, your floors, and if there's any large furnishings or cubicles within the space that you want to account for. You then manually input where your speakers are and what they're tapped at. And then the software provides an intelligibility prediction, either in STI or CIS, and then a sound pressure level prediction in decibels. And lastly, it's going to provide a comprehensive report of the design that you did within the software. This can be included in the job file for the building owner or the AHJ. Next, let's talk about what value could this software bring to system designers. Basically, it's going to provide the ability to address design issues early in the process to avoid changing specifications later in the design process. So if you address issues early, maybe you can change the requirements or possibly alter a room acoustics if that's possible. It also provides guidance for voice evacuation systems to ensure you're meeting the latest NFPA code requirements. It's going to enable virtual modeling for the most effective as well as cost-efficient system design. So you don't want to over-design a system and use way more speakers than you would need to. So the software could tell you that you're meeting requirements with lesser speakers than you had planned on using. And then lastly, it avoids time and costs associated with system pre-testing where that might be required. We also think it could offer some value to AHJs. Again, it's going to provide that documentation on how and why the system was designed the way it was. And it's going to reveal potential issues to discuss and address early in the design phase of the project. So you can start working with your AHJ on, this area we're just really concerned that we will never be able to meet intelligibility. So maybe you use a different type of speaker or you go to a different type of notification for that area. And you can talk about that during the design phase instead of when the building is supposed to be commissioned. It also could offer value to building owners. So it's going to reduce the chance of a non-code compliant system to, again, that could possibly delay commissioning. It will raise their confidence level that the voice evac system will be intelligible during an emergency to properly guide the building occupants. And lastly, again, it's going to reveal potential issues during the design phase instead of at the end of the project. So now I'm going to walk you through what the software actually looks like. So bear with me as we switch applications. And David, can you see the software?
I sure can. It probably will be showing up on the attendees here in the next couple seconds.
Okay. So I'm going to walk you through quickly how you could design an acoustically distinguishable space within the software. It's basically a series of tabs that you'll walk through. The first tab is your project information. So what the project is called, who is the designer of that system, your company's name, and then any notes that you would like to see on that final report out, you can type here. The next tab is where I'm going to enter my room information or my ADS information. So I'm going to look at my ceiling height in feet, the ear height or listening level. This is where the mapping occurs within the space. What type of network I'm using. Noise level, so this is going to be my ambient sound levels within the space. And then here is where you can either upload a floor plan, a JPEG, CAD file, TIFF file, or you can down here manually enter the dimensions of the space here, which I've already done that. The next tab is where I'm going to quickly get my speakers within the space. You'll see here on the drop-down menu is where all of the system sensor speakers are already preloaded. For quick and easy design, here's where you choose your tap settings. So for system sensor, we'll be looking at between 1/4 and 2 watts. And then the overlap type. This is how you want your speakers spaced within the room. So edge to edge, a minimum overlap, center to center, or you could choose a distance. Say you know you want to start off with them being spaced 20 feet apart. You could do that as well. On this next tab is where you can go in and individually make changes to speakers. So you can click on it here, and it's going to highlight over here. You can change any of the properties of the speaker, the tap setting where it's located, or you can delete it. And down here it's giving you a summary of you're using 13 watts of power, and you have 13 of the SPC speakers used within the space. Next, I'm going to turn on my mapping. So this is showing us, based on the design that we have in the room right now, what we would be looking at in terms of a prediction of sound pressure level. So you'll see here is my key over on the side, and based on how my speakers are designed right now, you know you want to be 15 dB over ambient. So you could say, well, I have plenty of speakers, maybe I'll delete some of these. And as you make changes, you'll see that the software is going to recalculate and show you how that changed your design based on the changes that you made. So it's really a neat tool to plan, to make changes. Maybe you don't know if you want to use a high fidelity speaker versus a high volume speaker. You can go in and map those two separately and see how it changes the audibility and intelligibility. So right now I'm looking at audibility. I'm going to change to STI, so we'll be now looking at intelligibility. Again, my key for STI is over here on the corner. So we're looking at a scale of 0 to 1. And based on how I have it designed right now, I'm at about a 0.7 STI. So we know NFPA wants us to be at a 0.5 or above. So I would say, based on that, I'm meeting the requirements. So that should give you some type of confidence level as to how your system was designed. Now, I don't want to forget to show you this important tab. This is the materials database that I talked about, and it's important that you make sure that this is filled in according to how your room is furnished or designed. So you'll see you can search by materials, whether it's concrete, brick, carpet, all of that is in here, suspended ceilings, and it takes into account the absorption coefficient of that material, which is then used within the software to determine an intelligibility prediction. So like I said, there's a lot more features and functionality of the software. I'm showing you how to quickly and easily design a system, but if you had to do more advanced troubleshooting or had a more advanced room you were modeling, you can certainly do that as well. There is a user's guide that it comes with. The last piece I want to show you is the report out that is provided after you design your space. This is a Word document. So you'll see here, here's all the information that I entered on that first tab. It's telling me I have 13 speakers within the space. Here's how they're designed. Now, I printed this before I turned on my STI and sound pressure level predictions. If you had that turned on, this would be color-coded to show what prediction levels you were at within the space. Again, here's my room layout. It also provides your reverberation time that's provided. It's analyzed within the software. And then here is a summary of all of my speakers and what they're tapped at, where they're located within the space. So that's a quick overview of the EASE Evac software. We're now going to go back to our PowerPoint. And David, can you see the PowerPoint again?
I I sure can.
Okay, great. So again, I just want to mention, because System Sensor, we're not selling or supporting the EASE Evac software, but if you do want to learn more about the software, you can visit evac.afmg.eu. Here, again, there's a lot more information provided. You can apply for a trial version that lasts 30 days, or you can also purchase the software from this site. And David, it looks like we're at our last poll question.
You bet. Thank you, Krista. And we do have a number of questions posted by the audience here, so we'll get to those here in just a moment. So the last poll question just is basically asking for your opinion. Will voice evacuation design software be helpful to you? So think of your current approach or current method of designing spaces such as this, and will it be helpful, yes or no? So you're coming in very quick here, so thank you for voting. And Krista, as I mentioned, we do have a number of questions here, so we'll take those in just a minute, and then we'll get the rest of them towards the end of the presentation. So thank you for voting. I'm going to close the poll. It looks like it's overwhelming. Looks like we stacked the deck, Krista. 93% are saying yes, some type of voice evacuation design software would be helpful.
Great. Thank you for voting, everyone.
Yep, thank you. So let me get back. Some of these questions have been with us for a few minutes here, so let me just respond to those. Kristen, I'm just going to read them as they've typed them here. So, can the system provide a computer-generated voice that provides a message that is an input through a computer keypad? And the second part is, can it be changed by the occupants depending on the event or changes in the space?
I'm assuming the question is talking about the EASE software.
I'm guessing so. That's, yeah.
And no, it can't. So the software is, you have to input, you have to design your space in the software. It's not going to tell you where you should put speakers or what they should be tapped at. You import into the software your room dimensions, the acoustics, where you're placing speakers, what they're tapped at, and the output that the software provides, again, is just the prediction of, several of those outputs. So intelligibility and sound pressure level for a voice evac system.
Okay, all right. Question along similar lines, can the volume be changed by the occupants as well? For example, say it's a conference center. One event may be a play, but another event might be something that's much more noisy, and he uses an example here of like a motorcycle inside or motorcycle races.
Sure. Where you would adjust, where you would account for that is on the first tab where you would enter the ambient background noise of the space. And I would say in that case, you should use your worst case scenario. So, if you wanted to design it both ways, you could leave your design the way it was with your play happening. That would be one ambient background noise, which is an input. You put that into the software, whatever decibels that is. And then you could also put it in with the motorcycle going and compare how that changes your predictions of both intelligibility and audibility of your speakers.
Okay, all right. Next question. Can you please comment on the methods of testing voice intelligibility? And he goes on to write, a test using a speaker for sound source into a mic is introducing intelligibility degradation. Mm-hmm. And he's saying he does pro audio work, and we generally use a direct signal into a system with an audio analyzer.
Right, and the meters that are used today, so intelligibility meters that I've seen, it allows for both ways. So you're right, if you're using it with a microphone, you could be introducing more distortion into the system, which will affect your intelligibility of the space. But I think there's also a way that that sound source is within the panel, and that you wouldn't have to use a microphone or a talk box, as I've seen they've heard they've been called. But I've seen it done both ways for voice evac systems.
Okay, all right. Next question is, how do we purchase the software? And you said go to evac.afmg.eu.
Correct.
And do we know an approximate cost?
Approximate cost is around $1,000 US.
Yep. And the reason we say US is that it's actually a German company that has manufactured EASE Evac, right?
Right, exactly.
Make sure that's clear to everyone. Maybe last question for this session. Does this software have the ability to interface with BIM or Rivet files?
To my knowledge, no, not at this time. So one of the ways to import your room or ADS, you can use CAD files. I know it's compatible with CAD, but to my knowledge, BIM and Rivet are not compatible files yet.
Okay, all right. So, Krista, why don't we get back to your presentation, and then we do have a number of other questions posted. We'll handle those at the end.
Okay. So we're just going to wrap it up now, and to summarize what we've talked about during this time is NFPA 72, the 2010 edition, it now incorporates intelligibility into the body of the code. So in Chapter 18, Notification Appliances, it's been moved from the annex into the body of the code. So this is really why we're focusing more on intelligibility. We reviewed some of the factors that can affect intelligibility, so you as designers can, take those into account and be aware of what's going to impact intelligibility in those spaces. We talked about System Sensors offering a full line of voice evacuation speakers, including our high fidelity line and higher volume line, depending on what type of application you're working in. And lastly, I just wanted to introduce you to the new voice evacuation software that's now specifically scaled for life safety systems. Comes to you from AFMG. They have been in the market for pro audio with the EASE software. This is now a simplified version for voice evacuation systems that we just wanted you to be aware of to hopefully simplify your design to meet these new standards. And that's all we had for today. So thank you for listening, and thank you for your time. I don't know if we have time for any follow-up questions, David?
Yeah, we sure do. In fact, there's a number of questions posted, so let's answer questions with as much time as we have remaining in this hour.
Okay.
The next question deals with NFPA 72, 2010, and the attendees saying it has a list of areas where intelligibility is not required. And he's saying the UFC 4-021-10 standard for mass notification says, quote, provide intelligibility in all normally occupied areas. So here's his question. Should I interpret that literally or try to seek clarification from my local AHJ?
Well, my opinion would say I would gain clarification if you have questions about what the requirements are. So again, you don't want to over-design, and be designing, more than you have to. So I would certainly ask for clarification from the local AHJ.
Yep. When in doubt, that's always our comment.
Absolutely.
The local. Okay. A question about the software. Does this software only calculate a contained space, or will it also calculate dB loss through walls or doors or windows?
There is there's functionality within the software where you can put walls and doors. However, I'd have to look in the user's guide. I don't know if it takes into account in the adjoining space how that wall or door is going to affect the dB loss because of that.
Okay. Okay.
So my safe answer would say no, but I would refer to the user's guide to see if there is a way to design it using walls and doors, but I'm not sure that it accounts for the loss of dB through those materials.
Okay, into the other space.
Correct.
Okay. The next one was responding to our 8-inch speaker poll question.
Oh, great.
And he's saying, isn't an 8-inch speaker with a wider frequency preferred over a 4-inch speaker, and why?
He's asking, is it preferred?
Yeah, he actually is saying, isn't it preferred?
Oh, isn't it preferred? Well, that is where our question comes from, that as more areas adopt NFPA and are designing for intelligibility, do you think that you will be seeing more of a need for, and I don't want to get hung up on the size of the speaker, but larger speakers typically have a wider frequency response, provide better sound quality, and they're higher dB. So you could use less of them and meet the same requirements as maybe using more of a 4-inch speaker, to meet the same requirements. So that's really where the question came from. Mm-hmm. Do you see, now that we're talking more about intelligibility and we're designing for intelligibility, will there be a greater need for this larger footprint, higher wattage speaker to meet these requirements? And the person who asked the question, I think typically it's right that because they're louder and they have a wider frequency response, that it might make sense, that we'll be moving towards that direction.
Okay, all right. A couple questions about using EASE Evac in an outdoor space. So the first question is, could it be used in a courtyard or an outdoor area framed by walls? And then the second question actually deals with an open parking garage.
Okay. I'm pretty sure you can, and I would say the way to account for that is within the materials database, that you would put nothing. So there's going to be nothing to absorb the sound. So on the parking garage, you would, put your concrete floor, your concrete ceiling, and leave the walls open. Same thing for the courtyard. If you put nothing in the materials database, that it would then account for there's nothing to absorb or reverberate the sound.
Okay, all right. A couple questions relating to ceiling heights here, and they seem to be, let's see, where's the second one? The first one is, how does a program address ceiling heights? And I know you typed that in one of your first tabs.
Right, so the first tab is where you're importing your room information, and that's one of the inputs. You need to tell the software how high your ceiling is.
Okay, and then he actually has to follow up for changing ceiling heights. Maybe it's a pitched ceiling or some kind of open area. And then also he asks also about non-rectangular ADSs.
That can be designed within the system, yes.
Okay, so changing ceiling heights as well.
Yes.
Okay, all right, good. Can we add our own absorption coefficients for surfaces? So can they customize the values that are in there?
I don't know the answer to that question. To my knowledge, no. I don't know that there is some type of upload feature where you could do that, but I would certainly say you could contact technical support for AFMG and ask if they possibly could add that to their database in the next revision, something that might not be in there.
Sure, sure, okay.
It's quite an extensive database, so I wouldn't be too sure that it's not in there already.
And Krista, I know we have the AFMG information listed on our website as well. If they went to that evac.afmg.eu, would they also find the technical support number?
Yes, they would.
Okay, good.
There's a phone number as well as an email.
Okay, good. A couple questions that link to creating just one room, or can you create the whole space? So is it just a one-off, I'm designing one room, or can I do, say, a whole floor plan with the software?
You can design, you can look at multiple rooms within that area we were looking at, but it's important that you keep in mind that you're looking at the acoustically distinguishable space. So that is, you know, if the ceiling height changes, the room acoustics change, you're going to want to design that as a separate space.
Okay. Okay. So the question that's related to that, can you design per room only or can you design an entire floor? Really, you're looking at those unique ADSs.
Correct.
Kind of one at a time, basically.
Correct.
Okay. All right, question relating to adding or deleting speakers. Can I create or import additional speakers? So after, say, a project is completed, can I add a speaker?
Yes.
Yeah.
So you can save your project and say something changed, you want to take speakers out or add speakers. You just go back into the project that you saved and make those changes.
Okay. All right. Question, I don't know, I understand, but maybe you do. How easy is it to modify speaker stock codes? Stock codes. What, you know what I'm talking about?
I don't know what that means either.
Okay. If the person that asked that question can give us some clarification through the chat feature, that'd be great. Can you import other manufacturers' speakers into EASE? Yes,
you can. So right now we talked about system sensor speaker data is already loaded into the software for you. If other manufacturers have the files that are compatible with EASE, you can upload those manually as well and use that within the software.
Okay, good. I think the answer is yes to this, but does EASE software include both wall and ceiling mounted speakers?
Yes, it does.
Okay. All right. Let's see. Can you recommend a site or a book for measuring ambient sound levels?
For measuring ambient sound levels?
Yep. Maybe we should get back to them offline?
Sure.
Okay, all right. Let's see. I'm just going through some of these we've asked already. Okay, here it is. What is the use of the sound pressure map?
So I think the question is the first diagram that we showed that was color-coded. That's showing you what your audibility is of the speakers, so that you're meeting, and it's showing you based on where you would be measuring within the space the audibility of that speaker. So that's going to show you that you're meeting the audibility requirements of the space. So if intelligibility, if that's not important to you, you could also ensure that you're meeting the audibility requirements of the space as well.
Okay, all right.
That's the sound pressure level tie-in.
Yep, yep, okay. To our knowledge, has there been an independent validation of EASE Evac for the U.S. fire alarm market?
To my knowledge, no. But I would say you should refer that to AFMG, but not that I'm aware of.
Yep, yep.
But I will say that AFMG has been, we talked about the standard EASE software. They've been in this market since, I believe, 1990 for the pro audio market. So although it might be new software for fire alarm and life safety, it certainly isn't new for pro audio.
Yep. Okay. Do you have a separate file for each ADS, or I think it's related to that floor plan question of earlier, do you have a building plan?
It would be a separate file for each ADS is how the software is set up.
Okay. Can you create custom speakers?
I don't know if I understand the question. So the speakers that you're using in the software are, it's data provided by the speaker manufacturer, and that's how the software takes into account, what the dB levels will be and intelligibility. So that data comes from the manufacturer. I don't know about custom speakers.
Okay. Back to a question earlier about recommending a book. One of our attendees, and this is, we don't have a way to verify this, but one of our attendees says Sound System Engineering, the author is Davis.
Oh, okay.
Is a book that's available on that topic. So
great.
thank you for contributing that. Let's see here. Can furniture be added to the EASE model? Is there a furniture database included with the software?
Yes, and sorry I didn't show that for sake of time, but it's called an object database. So yes, you can import, like I said, if there's cubicles or columns or furniture that is going to absorb or reflect sound, and that is, again, like the surfaces database, there is a database for that as well.
Okay, all right. A couple questions here I can answer. Will a certificate of attendance be issued for attending this webinar? Absolutely. For those of you that started with us and stayed with us, you will get a certificate of attendance that I know some state jurisdictions apply to some training requirements. This is not, however, a CEU-credited webinar, but you will get that certificate of attendance. And then the second question, can I get a copy of this presentation? And we will be offering this on our systemsensor.com/webinars page as a archive. So you can listen to it, rebroadcast it for yourself or your employees, really at your convenience. So those two things will be made available to you. Krista, is there an app for measuring ambient sound levels? An app?
Oh, I'm sure there is. I don't know a specific app right now off the top of my head, but I've heard from customers in the field that there certainly is, technology like that available. I just don't know right now what the app is.
Okay, let's send it back out to the attendees. If any of you know a good app, we'll mention that before we sign off here in a couple minutes. Krista, mathematically, how may dB loss due to doors or windows, let me see here, they didn't write it quite clearly. If I want to have more than 15 dB ambient on another room without speakers. Okay, it's that loss, speakers in one room, dB loss through doors and windows, but I want a 15 dB ambient in another room without speakers. I guess he's asking, can this software calculate it?
That's the part that I'm not sure of. That I would refer to the user's guide if the software can take into account the dB loss in the next space.
Okay.
I don't know.
Okay.
I know there's rules of thumb, though, for how much dB you can assume you're losing between a window or a door. I would say to be safe, put a speaker in that space, but I don't know that the software can account for that.
Yep. Okay. And actually, we've got a couple attendees that commented on that. The SFPE Handbook for Fire Protection Engineering has a table for dB loss through various doors, windows, and partitions. So thank you for contributing that. We also have a number of people who have commented on an app, Sound Meter app, which is an Android product, or available for Android is a good one, they said. There's a number for the Android market. That's another comment. There's an app for the iPhone called Decibel, and Sound Meter 1.6.5 works pretty well on an iPhone as well. So thank you for those contributions.
Perfect. Thank you.
Yeah, that's good. Getting some good attendee response here. We are at the top of the hour, and we promise to keep this to an hour. So on behalf of System Sensor, I do want to thank you for joining us today. As a follow-up, we will be sending you a brief survey in about an hour, and we would appreciate your help in filling that out. And we will plan to reward one of you that completes the survey with a $50 Target gift card. Thank you for joining us. This concludes our webinar. Please have a nice rest of the day.